Have you ever really stopped to think about what's going on inside a robot's head? I mean, we see them doing these incredibly complicated things, from super delicate surgery to building cars. But how? How do they actually do it? Well, today, we're going to dive into that invisible intelligence, the digital nervous system that makes it all happen. AI control. Okay, let's start with a puzzle that sounds simple, but is actually surprisingly complex. How does a robot learn to open a door? Now, you might think, just grab the handle and pull, right? But it's so much more than that. The robot has to see the handle, figure out how much force to use, keep its balance, and adjust if the door sticks. This one question, it really gets to the very heart of what robotic control is all about. So to really get how a robot tackles that door, we have to talk about robotic control. The best way to think about it is like a digital nervous system. It's the brain and the spinal cord that connect the robot's digital mind to its physical body, allowing it to interact with the world. So technically, an AI control system is the bridge between thinking and doing. It uses artificial intelligence to look at the world around it, to perceive what's happening, and then make a decision. After that, it sends commands to the robot's motors to actually perform an action. And this all happens in a constant, intelligent feedback cycle. This process has a name. It's called the control loop, and it's this incredibly simple but powerful three-step dance. Perceive, decide, act. And this isn't happening once a minute. This loop is running thousands of times every single second. It is the engine behind every single precise autonomous action you see, whether our robot is putting together a smartphone or assisting in brain surgery. So what's the magic that makes this control loop so smart? Let's pop the hood and take a look at the AI-powered toolkit that these systems are using to learn and adapt to the world. First up, we've got something called reinforcement learning. Now, instead of a programmer trying to code every single possible movement, they just give the robot a goal and what's called a reward function. So for opening that door, the robot gets a little digital reward for doing it smoothly and a penalty if it's jerky or fails. After thousands and thousands of tries, it literally teaches itself the best way to get the job done. Next up is machine vision. This is, for all intents and purposes, the robot's sense of sight, and it's incredibly powerful. AI algorithms are analyzing video in real time, identifying objects, tracking where they're moving, and guiding the robot's actions. This is how a surgical robot can follow a needle that's moving inside the body, or how a boat can spot and scoop up trash in a river. It's about seeing and understanding the world with an unbelievable level of accuracy. There isn't just one way to do this. There are kind of two main paths. You've got learning-based control, which is what we just talked about. It's perfect for messy, unpredictable situations. Then you have model-based control, which is great for structured jobs, like on a factory assembly line, where everything is predictable. The really cool part, the most advanced systems out there are actually combining both, so they get the best of both worlds. They're reliable and they're adaptable. And believe me, this technology isn't just stuck in a research lab somewhere. It's already out there transforming our world in some pretty amazing ways, from the operating room all the way to the factory floor. In medicine, the impact is just profound. AI control is giving surgeons real-time guidance for needle placements. It's handling super repetitive tasks like harvesting hair follicles with a level of precision that a human just can't maintain for hours. And this isn't about replacing the surgeon. It's about taking away fatigue and boosting their skill to a nearly superhuman level. And then you look at the factory floor. AI control is bringing a whole new level of efficiency. Instead of being stuck with rigid programming, these systems can adapt on the fly. They can handle parts arriving at random times or figure out the perfect way to stack boxes of different sizes. It just makes the whole production line so much more flexible and resilient. And the applications go way beyond that. We're seeing AI control being used to manage traffic in smart cities, to power robots that are cleaning up our rivers and lakes, and even, get this, to interpret brain signals from an EEG to allow for mind-controlled robotics. It's really becoming a foundational technology for automation in pretty much every corner of our lives. So this brings us to a really, really important idea. For all this talk about autonomy and robots doing things on their own, one of the most powerful uses of AI control is actually in boosting human abilities, creating a real partnership between people and machines. And this quote just says it all, doesn't it? The philosophy behind so much of this work is collaboration. It's about building tools that make the human expert even better at their job by giving them information and capabilities they just couldn't have on their own. So what does that partnership actually look like? Well, the AI can take over the boring, repetitive tasks that cause fatigue. It can provide haptic or touch-based feedback to literally guide a surgeon's hands.
And it can pull together data from all kinds of different sensors to give the human a much more complete picture of what's going on, so they can make better, more informed decisions.
So where does all of this go from here? Well, the future isn't just about making robots smarter. It's about making them safer, more reliable, and ultimately making them trustworthy.
All right, let's just quickly recap the big ideas here. First, AI control gives us autonomy, letting systems make their own choices. Second, it brings precision. We're talking superhuman accuracy. Third, it enables adaptability, so robots can learn and react to new things. And finally, and maybe most importantly, it creates a new kind of collaboration between humans and machines.
Looking ahead, the next huge hurdle is building trust. And that means creating AI that's explainable so that we can understand why it's making the decisions it's making. It also means engineering systems with almost zero delay, ultra-low latency for those critical moments, and building in rock-solid fail-safes to make sure things are safe even when something goes wrong.
And that kind of leaves us with one last, really fascinating question to think about. We've seen how AI control is letting machines master physical tasks with incredible skill. So as this technology keeps getting better and better, the real question we have to ask ourselves is, what tasks should we trust them with next?